Welcome to The Explainer. Today, we're diving into exactly how to evaluate the methodological quality of a research study so you can separate rock-solid evidence from weak claims. We are tackling a massive, incredibly important question. What do you look for in a good research study? We see bold scientific claims in our news feeds literally every single day. But how do we actually know which ones to trust?
So think about it like this. When we hear that a scientific prediction is confirmed, it doesn't automatically mean the underlying hypothesis is proven as absolute truth. Alternatively, if a prediction fails, we don't necessarily just throw the hypothesis in the trash. So how do we decide if the results are actually convincing? Normally, we observe something, come up with a hypothesis, and test it out. But once those results are in, we need a very specific set of criteria to know if the study provides genuinely strong support.
To become true research detectives, we're going to use this roadmap. We will start with reliability and replicability, and then we'll break down three specific types of validity: construct, internal, and external.
Let's start with the absolute foundation of any good study: reliability and replicability.
Before we can even talk about whether a study reveals the truth, we have to know if it's built on solid ground. A study is replicable if completely independent researchers can actually repeat the steps. That is the bare minimum. But it goes a step further. A research finding is reliable if someone repeats it and finds the exact same results. If you can't repeat a study's steps, or if you repeat them and get a totally different answer, the foundation is already crumbling.
But here is the catch. Getting the exact same result every single time, which is reliability, doesn't necessarily mean your conclusion is actually true. You could just be consistently wrong. Finding the truth requires validity, which is quite a bit more complicated. A study is valid if the conclusion you draw from it accurately reflects reality. Because asking, is this true, is a pretty massive question, we need to break validity down into three specific flavors.
Let's look at the first crucial prerequisite: construct validity.
A study has high construct validity if it successfully measures and manipulates the exact things it claims to in the hypothesis. In other words, did our methods actually do what we intended them to do? It sounds super simple, right? But developing accurate ways to measure abstract concepts is actually one of the biggest, most fascinating challenges in the behavioral sciences.
Let's use a fun hypothetical to test this. Say we hypothesize that loneliness causes depression. We figure, hey, if we decrease loneliness in elderly people, their depression should drop too. So we run a study in a retirement home and give the residents a cat to take care of. Let's suppose we find that depression really does decrease after they get the cat. Boom. Case closed, right? Well, is this study actually valid? Do the results truly prove that loneliness causes depression?
If we see a decrease in our survey scores, we have to ask a major construct validity question. What if we accidentally measured an entirely different construct with our questionnaire? What if, instead of depression, our test was actually measuring feelings of social exclusion? If that's true, our construct validity is completely shot because our method didn't reflect the true property we intended to measure in the first place.
And we also have to look at the manipulation side of things. What if taking care of the cat didn't affect their loneliness whatsoever, but instead just gave them a huge boost in feelings of responsibility and self-worth? The results would make it seem like loneliness caused depression, but in reality, we might have accidentally manipulated a totally different cause and measured a totally different effect.
Okay, if we assume our measurement and manipulation methods were perfectly valid for a second, we move to tool number 2, internal validity.
Internal validity is all about cause and effect. A study is internally valid if the observed effect is actually due to the hypothesized cause and not just some wild coincidence. We have to ask, can we confidently conclude depression went down strictly because of the cat, or did something completely different cause the decrease?
Think about the timeline for a second. Imagine our study started in the gloomy dead of winter and ended in the bright sunny spring. Honestly, maybe that simple change in the weather is what actually cured the depression. If there's a plausible alternate explanation like that, our internal validity is incredibly low.
Or, get this, perhaps it wasn't the relief of loneliness from the cat's company at all. Maybe the sudden increase in physical exercise from getting up to clean the litter box and fill the food bowl every day is what cured the depression. These plausible alternative explanations are the ultimate threats to internal validity. Whenever you see a study claiming that A causes B, you have to play devil's advocate and look for the hidden litter box.
Finally, once we've secured the internal logic of our study, we check its boundaries with external validity.
A study is externally valid if the relationship we found also holds up in completely different settings. In other words, can we confidently generalize these results beyond the walls of that one specific retirement home we tested? Can we apply this to different people, different environments, or even across different decades?
Back to our cat example. We have to interrogate our sample group. Will handing a cat to an angsty teenager have the exact same effect? What about middle-aged people, men and women? What about people from completely different cultural backgrounds? It is incredibly hard to make sweeping claims about humanity based on the results of only elderly people in a single building.
We even have to ask if the variables themselves generalize. Would a dog have the exact same effect, or is this highly specific to cats? If the original study had included younger people from diverse backgrounds and tested a whole bunch of different animals, we'd be way more confident in the study's external validity.
So, to summarize our mental toolkit for evaluating any research study, it looks like this. Construct validity. Did we actually measure and manipulate what we intended to? Internal validity. Is our hypothesized cause the real cause, or was it a change in the seasons? And external validity. Did these results actually apply to the wider world?
So, what is the big takeaway here? The next time you see a flashy headline making a bold scientific claim, don't just blindly accept it as undeniable truth. Use these criteria. Become a research detective. Ask yourself, what exactly did they measure? Could something completely random have caused the result? And does this apply to my life? Always ask, what is their cat? And did it really cure the depression? Or were they just scooping the litter box? Keep asking those questions, and you will never look at a research study the same way again.